Hello all, so we're back in the second part of the video. So for the first subtopic, we know that we are going to learn about the measures of central tendency or also measures of location. So we know that in measures of location, we have three values that we need to calculate, which is the first one is mean, the second one is median, and the second one is mode. Okay, so it says that mean is the average or one value for all units to have the same amount. That is mean. Whereas for the median, it says that median is the middle value for the data that we collected. And last one is the mode. So it says that mode is the highest frequency of the data. Okay, so let me give you one easy example for the mean, median, and mode. Let us go with the mean first. Okay, so let's say we have three students with the amount of money that they have. So let's say the first student, when we ask the first student how much money you have now, so let's say the first student say that I have 2 ringgit with me now. Then we ask the second student. So the second student says that I have 4 ringgit with me now. Then the third student say that I have maybe 2 ringgit with me now. So now we have our data for the amount of money, which is 2, 4, and 2. So if you can see that all the three students have different amount of money. So in order for all of the three students to have the same amount of money, we need to add all the value of the money, 2 plus 4 plus 2. So we will come up with 8 ringgit. And for this 8 ringgit, for the three students to have same amount, this 8 we need to divide with 3 because we have 3 students. So the value that we have is going to be 2.66667. Since that this one is about money, so we are going to have 2 decimal, so it means that we have 2.67. So in order for these three students to have the same amount of money, each of the students need to have 2.67 cents, so that all the three students will have the same amount of money. So that is the meaning of mean or average. Okay, and then for the median, so median, it says that median is the middle value for the data that we collected. So again, let's say we use the same example. So we have three students with the amount of money 2 ringgit, 4 ringgit, and 2 ringgit. So if we rearrange the value from the smallest to the highest, we will have the value of the data, which is 2, 2, and 4. So the value in the middle is 2. So meaning that our median value is 2. And then for the mode, mode says that the highest frequency of the data to appear. So again, using the same data, we have the data which is 2, 2, and 4. So we have 2 value of the data, which is 2 and 4. So for the data of 2, it appears 2 times, which is 2 and 2. Whereas for 4, it only appears once. So meaning that 2 appear the highest frequency, which is 2. So now our mode value going to be 2. Alright? Okay. So let's say that we are focusing on the group data. Let us go with the calculation of the mean, median, and the mode for the group data. Okay, so let us go with the first calculation, which is the mean. So to come up with the calculation of mean, so the formula of mean given to us with this one, which is the total of Fm divided with the total of F. So note that for the calculation of median or the measure of location, doesn't matter you are doing for population or doesn't matter you are doing for sample, the formula is still the same. Alright, okay, so you can find this formula in your formula booklet in the first page. So you look for the mean and standard deviation for the group data, so you can find this sample mean formula. So you can see that the formula given to us is the total of Fm divide with the total of F. So where can you find this value? Go back to the table that we just came up with the 5 additional information just now. So we can see that we have 3 values of the sum: total of F, total of Fm, total of Fm squared. So we just substitute the value of the sum here into our formula. So if you can see that for the total of Fm, so you can see the total of Fm from our table is 922. So divide with the total of F, which is the total of frequency. From the table we have 50, so we just substitute the value inside our formula. So we calculate the value, we come up with 18.44. So that is the value for our mean. So if you want to interpret or you want to know what is the explanation for this value of mean 18.44, so it means that in order for all of the 50 customers that we collected our data to wait with the same time to be served for the food, they need to wait for 18.44 minutes. So that is the meaning for the mean. Alright. So if you can see that in our calculation of mean, we have 2 types of mean, which is one is population mean, the second one is sample mean. So to represent our population mean and the sample mean, so we're going to represent population mean with the symbol of mu. So this is the symbol of mu. So this one is something like U with 2 tails. So this symbol we call it as mu. Whereas for the sample mean, we are going to represent sample mean with S bar. Okay, so whenever we see S bar, so you know that S bar is the sample mean value. And whenever we can see that the mu, that means it's the population mean value. So why you need to know the symbol for these two different value, for these two value, population mean and sample mean, is because in the next chapter, we are going to know where to substitute in our formula. So different symbol represent different value. Alright? Okay. So that is for the first value, which is mean. Let us go with the second value, which is median. So to calculate or to come up with the median value for the group data, we can use 2 methods, which is the first method, we are going to estimate our value from the graph. So we are going to estimate median only from ogive. We cannot estimate median from histogram. So whenever we want to estimate the median is only from ogive. And then the second method is we are going to use the formula. So how you want to know that which method that we are going to use? We are going to look for the keyword. Okay, so if whenever the question says that estimate for the median value, so estimate, you need to estimate from the ogive. You cannot use formula. If you are estimating the median value but you are using the formula, you will not get any mark, even your answer is correct. Okay, so estimate always from the graph, which is median, estimate from the ogive. And then for the second one, which is using the formula, if the question asks you to calculate, or if the question asks you to find median. So if the question says that calculate the median, so you are going to use formula. And if the question says that find the value of median, also you are going to use the formula. Okay, so the formula also will be provided in the formula booklet. So you don't need to memorize the formula. What you need to know is how to apply or how to substitute the value into the formula to come up with the median value. Okay, so let us go with the first method, which is estimate the median. So again, estimate the median is from the ogive. So you will need to have an ogive drawn on the graph paper. So I already have an ogive drawn on the graph paper. So this is the ogive for our table just now, which is about the time for waiting to be served for food. So this is our ogive. So before you start estimating for the median from the ogive, what you need to do is, first thing that you need to come up with is, you need to come up with the median frequency, median value for the data, which is the median frequency. So you know that median is half. So to have the median line here, so what we are going to do is, always we need to have 1 over 2n, which is n is how many units that we are having. So just now in our example, we have 50 customers. So means that that is our n. So if you have 70 customers, that is going to be your n. If let's say in another example, you have your unit or your element is 100 or 200, that is going to be a value of n. So in our case, our n is 50, which is 50 customers. So for this one, you will have 1 over 2, n is 50. So you are going to have the value is 25. Okay, so this 25 is not the median value. 25 is just represent where is your median value going to be. Okay, so 25 is 25 from the 50 customers. So 25 is the number of customers. So 25, you are going to look for 25 on the y-axis in your graph, which is representing the cumulative frequency. So 25 in your graph is here. So it's going to depend on your own graph. So look for 25. So when you found the 25, you need to draw a straight line horizontally from 25. Horizontally straight when it touches your ogive. Then you draw downwards vertically. So when it touches your x-axis, so that x-axis is going to be your median value. Okay, so let us zoom a little bit to the x value here. Okay, so if you can see that this line here is your median value. Okay, so this one is going to depend on your graph that you are going to draw later. What is the scale that you are using? Okay, so this one based on this graph. So if you can see that this line represents 15.5 and this line represents 18.5, meaning that from 15.5 to 18.5, the value is 3. We have 10 small boxes, meaning that each small boxes here represents the value of 0.3. Okay, so since that the line of our median is here, this line, so we need to know what is the value for this line here and this line here. So we add them all together, then we divide with 2, so we will have our median value. So we know that 18.5, to come up with this line, we have 0.6 gap. So means that 18.5 minus 0.6, we will come up with 17.9. Meaning that this value here is 17.9. And this line here, since that it has a one small box gap, so means that this line here is 17.6. So this one is 17.6. So since that our median value is in between 17.6 and 17.9, so to come up with the value, we add 17.6 plus 17.9, divide with 2, so we will come up with 17.75. So also we can say as round it up to 1 decimal, so it's 17.8 or 17.7. Alright, okay, so that is the value of our median. So our median is actually, hold on. So if you can see that to come up with our median value, so we have median is in the middle of, so it's in the middle of these two value. So 17.6 plus with 17.9 divide with 2, so we will have the value 17.7. So that is the value for our median when we estimate from the graph. Okay, so that is the first method using the graph estimate. So we have the second method, which is using the formula. Okay, so again, using the formula, you can find the formula for median given to you in the formula booklet, which is this one. Okay, so before we start with the substitution for the median into the formula, first thing that you need to do is you need to know from each of the classes that we have from the table, which class is the median class. So how to know which class is the median class? So again, you always need to start with 1 over 2n for the median. So again, our n is 50. So 1 over 2 with 50, we will come up with 25. Again, this 25 is not our median value. It just represents where our median lies in. So this 25, we need to look inside the cumulative frequency. So look inside the cumulative frequency. So you look at the first class, it's 2. So this 2 means that you have the first frequency and the second frequency lies in the first class. Then you look at the second class. Second class is only up to 12, means that the frequency up to only 12 frequency. But when you go to the third class, you can see that you have up to 30th frequency, meaning that 25th frequency lies in the third class. So when you know 25th lies in the third class, meaning that 16 to 18 is your median class. Once you know 16 to 18 is the median class, then you can start substituting the value into your formula. Okay, so the formula given to you is L plus 1 over 2n minus Fs divided with F multiplied with C. So we start substituting. So first we go with the L value. So L value says that L, you have the explanation in your formula booklet. So L says that the median class lower bound. So you know that your median class is 16 to 18. So the lower bound of that class is 15.5. So you substitute here 15.5. That's your L. And then you have plus. So you have plus. And then in bracket you have 1 over 2n. So again, just now we already calculate 1 over 2n, which is 25. So you just substitute 25. And then you have minus. And then you have Fs. So Fs, again in the explanation, it says that Fs is the sum of all frequencies before the median class. So median class is 16 until 18. Before the median class, you have two classes, which is 10 to 12 and also 13 until 15. So the frequency that you have before the median class is 2 and 10. So the sum means that you need to plus. So means that 2 plus 10 is 12. So that's why you have Fs is 12. And then you have divide with F. So F in the description or in the explanation, it says that F is the median class frequency. So the median class frequency is 18. Okay, so you can substitute with 18. And then last one you have multiply with C. So multiply with C. C, it says that in your, so the C in your explanation in the formula booklet, it says that your C is the median class width. So median class width, you can use two calculation or two method to calculate for your median class width, which is you can use the limit, you can also use the boundary. If you are using the limit, upper limit minus lower limit plus 1, which is 18 minus 16 plus 1. So you will have 3. Or if you are using class boundary, upper boundary minus lower boundary, which is 18.5 minus 15.5. So you will have your C, which is 3. So you substitute your C, 3. So you calculate for this value, so you will come up with 17.7. So note that when you estimate from the graph or you calculate using the formula, the value should be the same, or if you have any different value, it's not going to be too much gap. Okay, so that is for the median. Okay, and then we move on to the last value, or the last value of the measure of location, which is mode. So the same thing, mode, also we can use two methods to come up with the mode value, which is the first method we can use the estimation, which is we estimate from the graph, and the second method we use the formula. So still the same thing, if you need to estimate the mode, you need to estimate from the graph, which is estimate mode always from histogram. You cannot estimate mode from ogive. You can only estimate median from the ogive, and you can only estimate mode from the histogram. And then the second method, if the question asks you to calculate mode or find the mode value, you need to use the formula. So the same thing, again, the formula of mode is going to be given in the formula booklet. It's provided, so you don't need to memorize for the formula, you just need to know how to apply the formula. Alright, so let us go with the first method, which is estimate from the graph. So again, estimate mode is only from the histogram, so you need to have the histogram drawn on the graph paper. So I already have the histogram drawn on the graph paper for our time waiting to be served for food just now. So this is our histogram. So how you want to estimate the mode from the graph, since that mode is the highest frequency, so in our histogram you need to look for the highest bar. So if you can see that here is our highest bar, which is this one is the highest bar. So you need to draw the line, make it as the X, which is from this edge to the previous bar, and then this edge to the next bar, so making it become an X. So once you get the X, so make sure you draw the line straight using the ruler. Okay, so once you have the intersection point here for the line, you draw straight vertically downwards. When it touch your x-axis, so this going to be your mode value. So again, for this mode value here, we zoom a bit to the x-axis. So hold on here. Okay, so we zoom this one a little bit. Okay, so just now we know that how to estimate the mode. So we are going to draw an X for the highest bar. So we draw an X using ruler. So from this high to this high bar, so to the previous bar to the next bar. So this intersection line here we draw vertically downward. When it touch our x-axis, so this is going to be our mode value. Okay, so I zoom a bit from the x-axis here into this picture here. Okay, so we can see that this is our line for the mode. So it's still going to be the same thing. You know that each small boxes give you 0.3. So again, you can see that this line is in the middle of the two boxes. Sorry, in the middle of one box. So you plus the two value line, divide with 2, so you will come up with the value of the mode. Okay, that's how you estimate the mode from the histogram. Then the second method, again the same thing. We are going to use the formula whenever you want to calculate or find the value of the mode. So again, the same thing, you are having the formula given to you in the formula booklet. So you can find this formula, which is the mode, in the formula booklet with the explanation. So before we start substitute the value into the formula of the mode, first thing that you need to do is, from your table, you need to identify which class is the mode class. So how to know which class is the mode class? You need to look at the frequency, look for the highest frequency. So if you can see that in our table, in the frequency, the highest frequency that we have is 18. So meaning that 16 to 18 is our mode class. Mode class or model class is the same thing. Alright, so after you know 16 to 18 is the model class or the mode class, then you can start substitute the value into the formula. Okay, so the formula given to you, L plus F minus FB divide with F minus FB plus F minus FA multiply with C. Okay, so first we go with the L. So again, L says that model class lower bound. So again, we know model class is 16 to 18. So the lower bound is 15.5. So we substitute 15.5 for the L. Okay, then the second value we can have here is F. So F says that here F is the model class frequency. So model class is 16 to 18. So the frequency is 18. So we substitute 18 into our formula here. Then we have minus with FB. So the FB, it says here FB is the frequency of class before model class. So before the model class is 13 to 15. So the frequency of before the model class is 10. So we substitute 10 here. Okay. And then again we have F minus FB. So we just can substitute with the same value, 18 minus 10. And then again we have F again. So F we know is a frequency for the model class. So it's 18. Again it's 18 here. And then you have FA. So FA is frequency of class after the model class. So after the model class is 19 to 21. So the frequency is 9, which is this one. So you substitute into here. So you will have 9. And last one you have is the C. So again, the C, it says that in your description, the C, I'm changing the color, hold on. Okay, so the C, it says that C is model class width. So again, model class width, the width is, you can use two calculation or two method. You can use the limit, which is upper limit minus lower limit plus 1. So for the model class is 16 to 18. So 18 minus 16 plus 1, you will have 3. Or you can also use the class boundaries, upper bound minus lower bound, which is 18.5 minus 15.5. So you will have 3. So this is your class with 3. So you substitute with 3. After you substitute the formula, then you can start calculate for your value. So when you calculate the value, you will come up with 16.9. So note that when you estimate from the graph and when you use the formula to calculate, the value going to be the same or having the very small gap. So if you can see 16.9 from the formula and you are having 16.9 also when you are estimate from the graph, so means that you are having the same value. Alright, okay. So that is the first subtopic, which is the measure of location. Now we move on to the last subtopic, which is the measure of dispersion or measure of variation. Okay, so the measure of dispersion or the measure of variation, it says that to measure the spreadness of the distribution. Measure of spreadness of distribution meaning that you measure the spreadness of the value of your data or the value of your observation from the mean. Meaning that the farther the data or the value from your mean, you are going to have the bigger value of your measure of dispersion. Okay, so for this part, for the measure of dispersion, I'm going to explain further for the measure of dispersion in the third part of our video. Okay, so I see you in the third video.